Great Shavakadoo! And welcome to another episode of SIP Zoyas Math. I don't even know. I'm pretty sure I call this thing this channel a different thing every time. But either way, welcome. The topic for today is converting to standard form. Okay, so we're going to be converting from either what's called vertex form or translational form into standard form. So let's go ahead and start talking about our topic. There is a third form that a square function can appear in, right? And so for my students, right, this is the new form that we're going to see, or maybe old, depending on how much you remember your Algebra 1. It's called standard form, right? Standard form, right? And it takes the general form of y equals a times x to the power of 2 plus b times x plus c. Okay? And notice, right, that's a square equation. It's got x to a power of 2. It does have that other x in there, which is technically to a power of 1, but it's okay because x to the power of 2 is our highest and doesn't go past there. Okay? And so that's the general form that this thing is going to be taking. Ultimately, when we're done, we want to have something that resembles this. Okay? And a, b, and c are just real numbers. Right? They're not imaginary numbers. They're just real numbers. Okay, so a, b, and c. Right? And so let's go ahead and break that down from that big math term or math idea. And that's just a capital R written for real. So a, b, and c are real. That just means a could be pi. A could be -1. A could be 0. A could be 436.5. A could be anything that is not imaginary. Same with B, same with C. Okay, so similar to the multiplier on vertex and translational form, remember, those are our other two forms, A can be used to determine the concavity and whether the graph is stretched or compressed vertically. Right? Let's just pretend we didn't see that typo. It's okay, Andrew. Just slide it up and we won't see. And we can keep on going. Oh, wait, I gotta read that sentence. Dang it. To convert to standard form, you must multiply the binomials together. Okay, now we're good. The mistake just never happened. Okay, so we are going to need to multiply binomials together. Binomial, let's think about that. What does it mean? What's the first root word we see in there? Right? Bicycle. Bilateral. Having trouble brainstorming right now, but bi, right, means two. Okay? Let's think of all the other words that start with bi. It means two. Okay, so binomial. What does nomial sound like? Right? So nomial actually means number. And the origins of that, if I'm not mistaken, are from Greece and Rome. Or Greece and Latin. And you're going to see that all over the place in math. There's a lot of influence from the ancient Greeks and the ancient and from ancient Rome or ancient Latin culture. Okay, so what we're looking to do for all these equations is write the equations in standard form and determine the concavity and stretch/compression. Identify coefficients A, B, and C. Okay, so when we're multiplying binomials, remember, binomial just means two numbers, right, or number with two terms in it. Okay, so let's go ahead and look and just identify some binomials, right? X minus pi, that's a binomial. It's got an x term, and it's got just a constant term, a term with no variables in it. Alright, that's a binomial, right? Y minus 3, y is a variable. That's our y term. Minus 3, that is a non-variable term. Those are two different terms. That is a binomial. This is a binomial. 3x minus 2, right? The 3x, that's an x term. The minus 2, that's just a number. It's a non-variable term. Two terms, binomial, right? Binomial. Binomial. Two binomials multiplied together, right? It's written a little more explicitly there. And so what this is almost always going to result in is us having to do binomial multiplication. Okay, and it sounds a lot scarier than it actually is. We're going to go ahead and take a look at it. For some of us, this means doing box method. For some of us, this means doing FOIL method. You choose whichever is your favorite, whichever one you are the best at, and whichever one is going to get you those highest marks. So let's go ahead. Right, so we're converting from whatever this is to standard form. Okay, so what's stopping this from being in standard? It's this binomial multiplication. And it may be a little hard to see that binomial multiplication, so let's go ahead and break it down. Right, when we have something squared, how many times does that mean we're multiplying it? 2, right? So we have x minus pi times x minus pi. Right, and there we go. Those are the two binomials that are being multiplied together. And you're going to see as soon as we do that binomial multiplication and any distribution on the outside that potentially may be there, we're just going to naturally get our standard form after combining like terms. Okay, so we have this binomial multiplication. So me personally, my favorite way is the box method. Just good old, tried and true. Can handle as many nomial terms as you want. Can handle trinomials, quadnomials. Don't think that's a thing, but you get the idea. Right? I like box method. That's what I do. You like FOIL method? Go ahead and do FOIL method. I like box method. X minus pi. And that's how we do box method. We just write one of the terms for each square. In this case, we have 2 terms for each nomial. So we're going to do 1 term for each square, and so 2 boxes total on each side. Right? It's a 2 by 2. You can think of it like that. And then we're just going to go ahead and do the multiplication across. So in this box we write the product of x times x. What is x times x? Right? And I'm actually going to write this a little small. You may already know what x times x is, and if you do, good. You should. But if not, that's okay. Now you're going to know. Right? X times x we can write as x squared. X times x equals x squared. Say it one more time. X times x equals x squared. Okay? Right? Just because we have 2 x's being multiplied, that exponent is repeated multiplication. Okay? So now we're going to multiply to get this box. We're going to multiply x times negative pi. So, and we can actually just write this negative pi times x. Right? Just like that. And that's going to work just perfectly. And we don't even need to simplify that because that's just negative pi x. Weird, but okay, it's negative pi x. Pi is a number. Sure. Let's go. Let's do that. Same here. Pi, negative pi times x. So we're going to have negative pi times x. Right? In this last box, we're going to do negative pi times negative pi. Well, I know that a negative times a negative, that's a positive, right? And then pi times pi, that's just pi times pi, which is going to equal pi squared. Hard to write in that tiny space. Okay, but just pi squared is what goes right there, right? Pi times pi. And the negatives cancel, right? Negative times negative. So now what we do to finish off that method is we go ahead and write all these with an addition sign between each term. Because think about it, we now get all these different numbers, which we can add together to make the whole product. Alright, think about it like that. You know, we just found the area of a box that had this dimension by this dimension. So now we're just going to add up each of those small parts. And then replace it with what goes in there. So I'm going to, make this into 2 smaller steps, or break this apart a little more clearly so you can really just get a feel for what's going on. X minus 4. What? Where is my brain? Not in my head. And x minus pi. Okay, right there. Now this is equal to, right, and that's what we calculated, x squared plus, plus a negative pi x plus a negative pi x plus pi squared. Okay? Now we can go ahead and combine some like terms. There's a negative pi x right there and a negative pi x. Right? Those are both x terms. X to the power of 1, so we can combine them. Negative pi plus negative pi is negative 2 pi. Right? And that was the next term. So, and then we'll bring down everything else. So x squared minus 2 pi x plus pi squared. That's what that's equal to. So we can now go ahead back into here and substitute that into there. And that's exactly what we're going to do. One thing we need to pay attention to, though, is that negative 10 that's multiplying this. So when we substitute this, we want to use some brackets or parentheses, just to really emphasize that that negative 10 was multiplied to everything. Right? And, for, maybe for some more advanced students looking for another way to do this, God, I'm bound to make mistakes when I'm trying to talk and write. What you can do is you can actually distribute the negative 10 into one of these terms and then multiply that over here. That's going to give you the same answer if you do want to do that. Maybe you think it's a little bit easier. I don't know. Okay, and then just bring down that plus 36. Okay, now we have a negative 10 which is applied to this whole term. So we're going to distribute the negative 10 to each of these. Right? And remember, we distribute, one of the easiest ways to show we distribute is just with those arrows. It multiplies to everything in there. We have 3 terms in there. That is a trinomial, right? 1, 2, 3 terms, trinomial. So it's going to be multiplied to 10 of those things, or 10 of those things, 3 of those things. So we'll have negative 10 x squared plus 20 pi x minus 10 pi squared. Okay? And that's that distributed. So I just, negative 10 times x squared, negative 10 times negative 2x pi, negative 10 times pi squared. Alright, and that's what we get out from it. And we bring down the plus 36. Okay. Now, very last and final step, I'm going to go ahead and combine like terms. So, this is maybe where we may want to use our calculator so we can totally combine the like terms. But actually what I'm going to do is I'm just going to show my like terms by using parentheses to group these very strategically. Okay, so notice that's my x squared term. And check out how this is lining up with our standard form right up there. Okay, and I'll even write that above here. Standard form is going to be ax squared plus bx plus c. Okay, so I see that a is going to be negative 10, right? I can already see that because it's what's in front of the x squared term. B is going to be 20 pi because it's what's in front of the x term. Now c, this is where it's going to get a little bit weird. I'm going to go ahead and swap these two things around just so I have my positive in front. Not needed, but preferred. Okay, I am in the school building and it's late. Like no one else is here and I don't know what it is, but this building keeps making noises and it's tripping me out. Hopefully you guys see me in class tomorrow. Hopefully the school monster doesn't come and eat me, because right now that's what I'm pretty sure is going to happen. Because I just don't know what's making those noises. Okay. And I'm going to put parentheses around this because notice there's no x term in here, right? There's no variable, which means they are all just constants. They're all real numbers, and so they can be grouped together and thought of as a single real number, a single c. Okay, so writing it out, from here, so we have our standard form. Okay, we converted to standard form. Now there's a few things the question wants us to talk about or to realize now that we're in standard form. So first wants us to say what's a, b, and c. So a is negative 10, b is 20 pi, right? And I'm just, comparing it to this, right? Right, the b is what's ever in front of the x, so 20 pi. And then c is just that thing that's being added at the end. And so c equals 36 minus 10 pi squared. Okay, and that's our a, b, and c term, right? And you can actually calculate that on your calculator if you want. I'm just not going to because why? I'm a mathematician, not a calculator. So Okay, so that's that. Now the other thing it wants us to ask, what's the concavity in the stretch or compression? This is actually, right, this is where it's quite easy. This is what we already know. So the concavity is going to be the sign on the A, right? The x squared is the largest term. It's the highest power term, so it will determine the concavity. So the sign on this is what determines the concavity. We see a negative 10, so concavity is going to be down, which means we will have a maximum. And the stretch slash compression is going to be a stretch, right, because we have 10, which is greater than 1, so a stretch of 10. Alright? Beautiful. Okay. Hope you guys could hear that. That was a very satisfying knuckle crack. Just perfectly timed, so we can go on to our next example and crush this one. Okay. So, again, we're looking to do the same do. I'm going to put some dots, a dotted line here just to separate it. Okay, so we're looking to convert to standard form. We may have to do a little bit extra this time. We know, first off, if we want to get to standard form, we can't have this binomial squared. Can't have that, so let's go ahead and rewrite that. And we know that binomial 3x minus 2 squared is equal to 3x minus 2 times 3x minus 2. Alright? Now, so we can do that binomial multiplication, and you can do that now if you want, but I'm first going to take care of this minus 3, which is on the y. Remember, when we look at our form, we want y isolated, nothing next to it. So let's go ahead and take this 3 to the other side. So y equals 2, 3x minus 2, 3x minus 2. Those are being multiplied together, of course, and then plus 3. Okay. Alright, so now let's go ahead and do that binomial multiplication. Good old binomial multiplication. Nothing like it. After a long, hard day, just come home to a nice glass of binomial multiplication. Available at your local grocer. Available at your local math classroom. There we go. That's the real advertisement, right? Come on in. Stop by Mr. Zoyas' math classroom to get a nice cold glass of binomial multiplication. Made fresh to order every time, all the time. Okay. Right, so I'm just going through the same steps before. I like box method. I'm doing box method right here, and I'm just multiplying these things to get what's in here. And I'm going a little bit on fast mode because you saw me explain this. So 3x times negative 2, negative 6x, 3x times negative 2. And some of you clever cats out there might be noticing a pattern, right? So you may be noticing what happens when we multiply two binomials that are exactly the same together. Okay, and if you are, good for you. I don't want to go too much into it because that's kind of a whole topic on its own. But notice it's going to be that first number squared, right? So 3x, we're going to square that, minus the first term times the second term times 2. Okay, so first term times second term times 2, that's going to be negative 6x times 2 is negative 12x. Alright, and if you don't believe me, just go ahead and add these things up, right? Look, this is what it adds to. Negative 6x plus negative 6x is negative 12x. Right, it's a pattern. Negative 2 times negative 2 is 4 plus 4. Okay? Right, and that is ready to be plugged back in up to there. So let's go ahead and do that. So, again, we have that 2 that's multiplying everything. So we're going to write some brackets just to remember that it's going to have to be distributed to all that stuff. Alright. and is equal to. Okay, so we plug that in. Now let's go ahead and do the distribution. Do. I'm sorry, my Floridian just kind of came out there. It's prone to happening sometimes. You can take the boy out of Florida, but you can't take the Florida out of the boy. Yeah, I thought I messed that up at first, but I didn't. That was a close one. That would be my second mistake for the video. Ugh, I don't want to think about that. Okay, so 2 times negative 12 is negative 24x. 2 times 4 is plus 8 plus 3. Alright, now here's where we want to go ahead and combine like terms. That's our only x squared term, that's our only x term, and then we have x plus 3. And 8 plus 3. Right, and those are our like terms. They don't have a variable in them, so we can combine those. 8 plus 3 is 11. So we have negative 24x plus 11 and 18x squared in front of it. Right, and so that is our standard form. Beautiful. Excellent. Now, A, B, and C. Let's go ahead and find out what A, B, and C are. So A equals 18. Right, just with the number in front. B is equal to negative 24. C is equal to 11. Okay? What's a concavity? Oh, I don't know. I'm going to look at this A term, which happens to be a positive. So I'm going to say concave up, which implies a minimum. And as far as a stretch or compression, well, I see 18 is bigger than 1, right? So that's going to be a stretch of 18. Okay? Awesome. Cool. Definitely did not anticipate the amount of work I was going to need for these problems, or the amount of space. But we're going to fix that with a nice dotted line, right? Just to keep it all separated, right? You got to keep it separated, just like the song tells us to. You're not 90s children, so you may not get that. Okay, so remember, we got some binomial multiplication going on. Now this one's a little bit different. This is kind of a different form, not different form, but just like a different. It's just different from what we've seen. It's not a different form, but it's not the binomial squared, right? It's two different binomials. And we actually don't have a name for that form. Correct me if I'm wrong. You can get Z-Bucks if I'm wrong. But I'm pretty sure we don't have a name for that form. We will see it, but understand that that's kind of just like a mix of, that's just kind of like a different version of binomial form. Alright, so we still see that binomial multiplication that we can do. So let's go ahead and do that. So over here, I'm going to do my binomial multiplication using box method because it is the best. FOIL method can suck it. And 2x plus 5. Okay, and so then I'm going to do that multiplication. 2x times x for that box is 2x squared. 5 times x is 5x. And 2x times negative 7 is negative 14x. And negative 7 times 5 is negative 35. Cool. Coolio. Ooh. Okay. Man, I wish there was a way to speed these up. These problems are surprisingly long. Okay. Man, lucky for you guys, you can speed this up. You can put me on fast forward. I can't put me on fast forward. Alright. So, over here we realize that this binomial multiplication means that 2x plus 5 quantity times x minus 7 quantity is equal to 2x squared plus 5x minus 14x minus 35. Alright, and combining like terms, right, we see the x's, the x terms are like terms, so 5x minus 14x is going to be negative 9x, and we'll just bring everything else down. Okay? That's what we're going to go ahead and substitute into there, right? We calculated what that multiplication is. So 2x squared minus 9x minus 35. Okay, and then we're going to do the distribution, right? And these are just very, you know, kind of like drilling problems. They have us cover a lot of skills in one problem, which honestly, these are the best ones. These are the ones you want to look to do. It's gonna, it's like a full mind exercise. It's like a full body exercise, but for math, right? You're hitting all those different math skills, getting a nice even tone. You're not that weird guy just like, you know, pumping on the isolated muscle machine and getting just like one really jacked muscle while everything else is just like disproportionately small. You're getting a nice, beautiful, strong math brain. Alright, so 8x squared, 4 times negative 9x. 4 times negative 9 is negative 36. Negative 36x. And then 4 times negative 35. Well, that is going to be mental math. 140. Yeah, because 70 plus 70. So that's going to be a negative 140. Okay, distributing that, that's what we get. And this is our final standard form. Okay, now just reading it off. A is equal to 8, B is equal to negative 36, and C is equal to negative 140. Concavity, it's a positive, so it's upwards. It's a min, which means I'm in, and stretch slash compression is going to be a stretch of 8. Cool. Okay. Whew. Awesome. If you want to pause the video, I do not blame you. I'm worn out just from doing these. So this is the final problem. The one problem to rule them all. This is actually a fantastic problem, right? This is a great multi-layered problem. Dude, you're gonna see this on your quiz. Just completely honest with you. This is a quiz question, right? This is actually the epitome of a quiz question. Just exercising multiple skills, you know, getting you to think dynamically, be that dynamic math thinker. Right, so let's go ahead and do this. So find the solutions to the system of equations. Right, and this is probably the first time we've ever seen a system of equations with a square function and a linear function. We realize that's linear because it just has x to the first power. Alright? But now how do we solve systems of equations? Well, there's many ways. The optimal method of choice here is going to be substitution. We're just going to substitute y in for y. Because watch what happens when we do that. And I'm going to start this problem over here because it'll probably be a little bit lengthy. 84 minus 14x. Man, this one's just going to be a beauty. It's just, this is a great problem. You can already tell. Like, you can just tell. Got some great layers to it, like an onion. Great layers like an onion. God. You can tell it's late just by the things I'm saying. Alright, okay, so we substituted y in for y, right? That's how we substitute. So we took all that, we put it there. And so what that's going to do is get rid of our y's, so now we just have a x variable to solve for. Okay, because remember, we're solving for the system, so we first want to get one of our variables. Solve for just one of our variables. Alright, now, so we're going to want to isolate our x, and there could be a handful of ways you're thinking of doing this. You could first think that, hey, let me go ahead and subtract this 2x over, or maybe add this 14x over to here, so I have all my x's on the same side. But you're gonna run into a problem, and that problem is going to be that you have this square term right here, right? You can't mix those terms together. they're ultimately going to stay separated. And that's actually, that's a detrimental problem. If you can't ever combine them, how are you going to solve for it? Remember, our goal for this is to get x equals blank. So how do we do this, right? This is a really interesting problem to solve. Well, of course, right, some of you may be, using context clues and be like, oh, we're converting to standard form, so we're going to, do the binomial multiplication, right? And very clever, okay? But if you were not thinking that, how you could know to do that, right? Say we didn't have that context. You could just look at this as, how can I make this more simple? How can I break this down further to then see what I can do with it? And the answer to that would be, get rid of this binomial squared. Alright? So we know that a binomial squared, right, that's just 2x minus 4 times 2x minus 4. And then bringing down that plus 2x, right? Plus 2x. Right? We know that's just that. So over here, or maybe down here, I'll do my binomial multiplication with my box method, which is just clearly superior. If you think otherwise, or just all hope is lost on you. I'm just kidding. That was harsh. But at the end of the day, we know which method's better. So 2x times 2x is 4x squared. 2x times negative 4x is negative 8x. Negative 4 times negative 4 is 16. Psyching you out. You thought I was going to do that box. It does not matter the order you do this in, as long as you just find out the multiplication for each box. Negative 4 times 2x. Right, and that could be pretty easy to prove how it doesn't matter the order you go in, just because, right, the multiplication is not going to change just because you did one box first. Alright, so that is equal to, now we're going to add up all those terms. So we have 4x squared minus 8x minus 8x plus 16, which is equal to 4x squared minus, and we're going to combine these like terms, right? We notice we have two x terms right there, so minus 16x plus 16. Some nice numbers in there, right? Look at them, they all have a multiple of 4. Clever things to notice that could come in handy. Okay, so let's go ahead and take this and plug it in. So we're going to have equals 4x squared minus 16x plus 16 plus 2x, and we're just going to bring on everything else down. Right, and so just quick review, we found out what this binomial multiplication was, and then we plugged it back in. That was the overview of what we did. I know there's a lot of processes going on here, and it can be easy to lose sight of the big picture. Okay, so now I've broken it down. Now let's go ahead and start seeing what we can do with this. Alright, so the question is, what can we do? And if you want to pause the video and say, what can I do with this, really think about it before I tell you, that would be a great exercise. If you didn't, shame on you. I'm just kidding. Still love you just the same. Still going to get good at math just the same. And what we're going to do is we're going to combine like terms. Right, so first over here I have x terms. A negative 16x and a plus 2x. So we're going to combine those. So we'll have negative 14x plus 16. And then just bring down what's over here. We didn't touch the left side. Now, there's a very big opening here. Something that allows this problem to be solved. Alright, pause the video, see if you can tell what it is. Okay, what it is the minus 14x and the minus 14x. If we add 14x to both sides, watch what's going to happen to that term. Kapoof. It's gone. And that's the key to this, because up until there we had these two x terms and we don't know how to reconcile that. We just don't have the tools to handle when there's a x squared term and a x term in it. We just don't have the tools for that. If it's like that, maybe without all this other junk on it, sure, we've done that. We can just take the square root. But we can't just take the square root of this. This stuff's going to either get caught up under it or be on the opposite side of what we're taking the square root of. And either way, that just doesn't give us a pretty answer. It doesn't give us an answer we can even work with. So, it doesn't even matter if it's pretty, it's just we can't work with it. Right? But when we add this 14x, very special case, what happens is it gets rid of that term entirely. Okay, so now let's go ahead. Now we're solving for x. That means we're isolating x. So we're going to subtract 16 minus 16. And that's going to be minus 100 over here equals 4x squared. Alright, going over here. Alright, it's a big, beautiful math problem. So we're definitely going to take up some more room doing this. We're not done with it yet. So let's go ahead. Negative 100 equals 4x squared divided by 4 on both sides. It's negative 25. Remember, I divided by 4 because I have that 4 that's multiplying x. Negative 25 equals x squared. Well, look at that. We have a x squared alone, cornered, ready to be undone by taking the square root. We take the square root to get rid of that square. Don't forget that plus or minus on the minus 25. Now, I'm going to make a more advanced jump. Right? Instead of showing how we pull out the negative 1 and then we eventually separate that from the radical and the square root of negative 1 is I, I'm just going to pull the I out altogether. So plus or minus I to the square root of 25. Sorry, times the square root of 25. And that square term goes away. Right? And so the square root of 25, as we know, is just 5. So plus or minus imaginary 5 equals x. Beautiful. We're done, right? Oh no. Right? And that is the beauty of this problem, right? And this is just why it's such a good problem. It's just a juicy math problem, right? Really sink your teeth into it. Really flex those skills. Right? Why are we not done? Remember, find the solutions to the system of equations. So sure, we found a solution to x, but also what do we need to find as well as x? That's right. Okay, so I have a moment here, so I'm looking for y, right? That's the final part. So I have my x. I need to find my y. So I can find my y one of two ways. See if you can figure it out. We can find it by taking this and plugging it into this equation, right? Take our x, plug it in here, and then see what y is. Or we can take this and plug it into the top equation up there, right? I'm going to choose the top one. It's the simplest, okay? And that's not like a cop-out kind of simple. That's like a I'm going to work smart, not hard kind of simple. Okay, so writing that equation again and leaving my open space for the plus or minus imaginary 5. Because that's what x is equal to. So I'm going to write plus or minus imaginary 5. Okay? Now, I have plus or minus imaginary 5 times negative 14, and a lot of us may have never seen this before. We don't know how to deal with it, right? Negative 14 times a plus or minus of something. What do we do with that? Well, there's a few ways we can handle it. And spoiler alert, they're all just going to come out to be the same, plus or minus. So let's go ahead and analytically break this apart. So if we had negative times a positive, that first set, well, that would just be a negative, right? So that would be negative 14 times 5 times I. I know I'm writing the I on the right this time. It's a little weird, but it's okay. Normally we write it in front just to signify the imaginary term, but like I said, that's okay. Now, let's think if we do the negative times the minus term, right? So negative 14 times a negative 5i. So what's a negative times a negative? Well, that's a positive, right? So that would be a positive 14 times I5. or just a positive right there. Okay, I mean, so look at that, right? We just ended up flipping this upside down to go to there when we took the negative of it. But realize, did anything really change? I mean, remember what this says, right? This is a number plus or minus 14 times 5 times the imaginary number, right? It's or. Does it matter? If I give you an or of something, does it matter which way we do it first? Absolutely not. That's the beauty of or, right? You have either or. So that is still just the same as that. Okay. So now we want to go ahead and simplify this as much as we can. So we're going to have 14 times 5. I'm using my calculator right now, just going to confess. Forgive me. But, it's okay to use our calculator for some of those bigger calculations. That actually wasn't that bad. I feel really guilty now. That was just 70. Right. I'm going to put the I back in front just to be proper about it. Okay? And remember, that is what y is equal to. Cool. Awesome. So that was a big one, right? And so we're done, right? For the most part, we're done. But we still need to write our final points. So to write our final points, realize we're going to have two solutions to this because ultimately we have a square term, right? And as we can see, there's two values of x and two values of y. But now, which one associates to which? That's really the good question. So what we want to do is we want to go back here and we want to imagine that if we plugged in the positive version of this into this equation and see what y would equal. And we know that then that would be 1 point. So we could have I times 5. That would be our x term, right? Comma. So that's our x term. Let's find out what our y term would be. So when we plug that in, the negative times the positive of I5, well, that would just give us this negative version of it, right? So we would have negative 84 minus 70i. And that's how you know this is really just a good math problem. I mean, right? Look at that solution. Just what? Like whoa. Wow. Right? Just, it's big, it's beautiful, it's eloquent, it doesn't make sense, it's mysterious. And let's go ahead and find out what that second point is. So now if we had the negative imaginary 5, right, so we would have the negative of that, so the negative times the negative, that would be the positive. So we would have minus 84 plus 70i. Right, and these are our solutions. Two solutions, both of which are complex. Get a load of that. Crazy. Just absolutely crazy, right? God, that's just a beautiful problem, right? I don't think we skipped a single skill that we've covered this semester. I guess maybe inverse functions, right? We could take it a step further with that, but as is, just holy moly, right? That was great. I feel like I need to kick back and just I don't know, just bask, right? I need to bask now. So okay, cool. So one more point I want to leave you with is that realize that in and of itself, if we want to put these on the imaginary number plane, these would be points on our imaginary number plane, right? So go ahead and try and fathom that. These are coordinates, right? Meaning they have 2 points, an x and a y, which then also lie on an imaginary number plane. I know. Let your little brain fathom that, right? A point, right? A whole point that has smaller points that lie on a plane, right? Planes on planes. I heard you like planes. Okay. Awesome. And really just go ahead and give yourself a pat on the back for sticking with this. Again, just, I mean, look at this, really. Be proud of that. Be very proud of that.